So now we are getting into the idea of analyzing accumulation functions. So in this first example, we've been given an accumulation function g of x, and we're trying to determine all x values where it's increasing, decreasing, and has a relative max or min. So if we're looking for intervals of increase or decrease, we should first focus on the derivative. So g prime of x equals the derivative with respect to x of this definite integral, and using FTC part 2, that is f of x. So g prime of x equals f of x, which is this graph. So from looking at this graph, I should be able to create a sign chart about my derivative, because this is my derivative. We're looking at this derivative on a closed interval from -2 to 5, and I see that my derivative equals 0 at 2 and 4. So now if we compare my derivative to the original graph, what's going on? So from -2 to 2, my derivative is positive, so increasing. From 2 to 4, it's negative, decreasing. And from 4 to 5, it's positive, increasing. So we know it's increasing on the intervals -2 to 2 union 4 to 5 because g prime is greater than 0. We know it's decreasing on the interval 2 to 4 because g prime is less than 0. So now from this sign chart, we can see that there's a max at 2 and a min at 4. So let's summarize those answers. C, g has a relative max at x equals 2 because g prime of 2 equals 0 and g prime changes from positive to negative at that value. So let's summarize part D the same way. G has a relative min at x equals 4 because g prime of 4 equals 0 and g prime changes from negative to positive at this value. So we can analyze accumulation functions to determine where they're increasing, decreasing, and have max and mins, and we can justify our answers.